HVAC 360 is brought to you today by the Paperwork Pig. Was one of your New Year's resolutions to clean up a little bit around the office? Need to have someone to blame for lost documents but haven't had a dog since grade school? Introducing the Paperwork Pig, your one-stop solution to organizational nirvana. Pile of papers? Gone. Important memo? Never got it. Not to mention the pranks you could pull with the piles of Paperwork Pig output. But you didn't hear that last one from us. Paperwork Pig also acts as a great stress reliever. Yell at it all you want. He doesn't give an oink. Pick your pig out today. Hey everybody, welcome back. Matt Nelson here, your host for HVAC 360, helping you be the best and the brightest in the field of HVAC. We do that by sharing lessons learned and talking to experts in the field, but I don't stop there. No, I want you to encourage you to double down on your weekly helping of HVAC knowledge by hopping on over to HVAC360.com and join my growing community of people just like you. Don't forget to mention the membership site, still open at a deep discount for a limited number of people for a limited amount of time. Visit the website today. All right, with that out of the way, what's up for this week? This week I wanted to share some information about cooling towers and some things that I've learned in the field. Just some niceties, things you should think about during design. So I guess not everybody knows about cooling towers. They're not exactly on every project. I think the one neat thing to do, you can actually go to Google Earth and take a look at large downtowns. If you go to like New York City, Chicago, just pick one around you. I mean, even Cleveland would have the same thing. If you look on the rooftops of large buildings from a Google Earth view, you'll see the round propeller fans that are kind of an indication of that's where cooling towers are. They're all over the place, especially in big buildings. So what exactly are cooling towers? I'm going to kind of broad brush this. A lot of you may know what they are, but they're actually giant air scrubbers. No, just kidding. But they actually can be. That's one of their main features is they just kind of aggregate all this stuff that's in the air, whether it be dirt, dust. There's a lot of cottonwood around here that gets sucked in there from the cottonwood trees. They are very efficient at scrubbing the air. So there's a lot of dirt and debris and stuff that actually gets in there. But primarily they are used in reality for rejecting heat into the atmosphere using water. They're essentially used because they're better than once-through condensers. So when you have a process that you want to use water as your cooling medium, the first option that you have is to use what they call a once-through cooler, which basically means, and it's as crazy as it sounds, there are still installations out there of varying sizes of what this is. But they connect a potable water source. It doesn't necessarily have to be potable water, but in a lot of cases it is because it's connected to the municipal system. They connect a potable water source and they run that cold water, because the water is, around 50 degrees, depending on where you are in the world. But it's around 50 degrees. So it can actually cool down or you can reject heat to it through your compressor. Now, they usually have like some sort of shell type of heat exchanger that it actually goes through. But then it goes through once and then it dumps down the drain. And when water was cheap and, nearly free, that was a great solution. But that is no longer the case. So the next step in the evolution of things is to actually recycle that water. There's still a lot of water use. There's evaporation, there's blowdown. We'll kind of get into that a little bit more. And it's still not a great solution in some water-starved areas. So you really need to check the financials, whether it makes sense for you and your project to use a cooling tower. Does it make sense? Obviously, so these are some of the things that you can think of during your design, and you need to weigh those options very carefully. So, the types of cooling towers, there's a lot. I linked a couple of videos in the show notes. If you go to hvac360.com/114, there's a video links for YouTube. You can search it up on yourself. It's just a couple that I found. Also, if you have an ASHRAE handbook handy, go to HVAC Systems and Equipment. Chapter 40 is what you'd want to search for. And they have a nice rundown of cooling towers there as well. Primarily what I'm talking about, and the experience, like 90% of what I've dealt with in my career, are induced draft cooling towers. Now, there's two varieties. There's a cross-flow and a counterflow. And all that means is that typically the air is coming out, or is going in on the sides and coming out on the top, where there's a big prop fan. And when it goes in the sides, if the fill is oriented so the water kind of trickles down from top to bottom and the air is coming in through the sides, then you're going to have a cross-flow configuration. So the water and the air are crossing. Now, if you have a counterflow, what that means is you're still going to have air coming in from the sides, but you're going to have it turning 90 degrees and going straight up. So that's going to be counter to the water kind of trickling down the fill from the top. So that's kind of the difference between the crossflow and the counterflow. So you might ask, what are some of the components that you're going to find in these induced draft cooling towers? Well, obviously, I think the important thing, and I'm going to hit on some things that, I find novel or were important to me. The structure is going to be the first critical component of selecting or knowing about a cooling tower. You can make cooling towers out of different materials. You can make them out of wood. These are the biggest and the most industrial, but they would be that you can make them out of wood, and that's perfectly fine. I don't see a lot of those, to be honest with you. I think that's more of an older variety. And in fact, I've never specified one. I've never really worked on one, but I know they exist. And it is, especially in an industrial application, it's cheap, it's wood, you can maintain it, all sorts of things. But typically the two varieties that you're going to see galvanized, and you're going to see stainless steel. Now, typically, if you want the cheapest cooling tower, it's just going to be all galvanized. If you want to step it up a notch, you're going to make some of the components in the cooling tower, you're going to specify them to be stainless steel, to be resistant to, rust, and, even galvanized is resistant to rust to a point. But the longevity, you could really scour the stainless steel and clean it, and it would be just fine. However, you could have the entire thing made out of stainless steel. Those are premium. Now, I guess it's important there to note that there was, one project in my career where we went in and we were going to do a replacement of the cooling towers. Now, we didn't look at the cooling towers too closely, and we had the manufacturer's rep come in, take a look at them, and see what his opinion was. And what he said was, you guys are going to be crazy. These are all stainless steel. To rip out stainless steel cooling towers was just unheard of. It was a retrofit application. We weren't changing the load a lot. We weren't changing a lot of things. We just wanted to update and upgrade the cooling towers themselves. So we ended up replacing some of the components in them, but we left the structure alone. So we kept that stainless steel. So it's important to know what you have before you go changing some things out, and know that that's an option to add some stainless steel into a galvanized cooling tower. Just there are certain components that are going to last a lot longer. If you have the sump, stainless steel, that's going to help you out. Different pieces, but again, talk to your manufacturer's rep. They're going to be the most knowledgeable about this. Now, another thing that's in within the structure, obviously, is the fan, that induced fan that sits on top, and that's either going to be belt driven or it's going to be a gear drive. So those are kind of the two ways you can get it. It's not necessarily, I don't even know, they might make a direct drive now, but typically in the past I've seen it either gear driven or a belt. Now you're going to have a lot of times you're going to have a VFD motor that's going to be associated. The fans are big enough, you're going to require really a VFD motor. But that hasn't always been the case. Typically, you'd see cooling towers with a single-speed fan. If it was a little bit fancy, you might see a 2-speed fan motor for that particular cooling tower. And, that would be it. With a VFD, that gives you, obviously, a lot more play to be able to dial in the temperatures, coming back from the cooling tower. So, another thing, especially dealing with the fan, is that you're going to have a vibration switch. Now, vibration switch is a critical component to the cooling tower fan, because if you have an unbalanced fan and you're like, well, it should be balanced, right? Well, in wintertime, you can still run these in wintertime applications. And obviously, I'm talking to those people in freezing weather climates, but you're going to have water that might build up on the fan blades themselves. Now, if there is an imbalance, you can really damage that fan, and you might have components flying off, and that's not good. You can even have ice flying off. If there's enough vibration in there, what the switch does is if there's enough vibration, it will kill the operation of the fan. So you don't have fan blades flying off, or you don't have sheets of ice from the fan blades, flying off and being, thrown, hundreds of feet. That's dangerous. So the vibration switch is there. That's one of the things that it's not always easy to test because it's not really safe to be in the cooling tower while the fan is in operation. The vibration switch tends to be right by the motor in that location. So it's not safe to test. But, it's there nonetheless. I just want to make sure that if it's not there, it should be there as a safety device. Now, there's going to be a drift eliminator that's going to be underneath the fan in these configurations typically, and that's to kind of prevent as much moisture from being evaporated as possible. And what I mean by that is you're going to have, because all the air is being sucked up and out the top, this is a chance to kind of reduce the amount of moisture that escapes. There's going to be some that's it's in the air, it's humidifying the air that you're not going to get. But there are other things that when you force it through this drift eliminator, you're actually going to get some water to condense out and drip back into the cooling tower. So drift eliminators are important. The next component you're going to have fill. Now this is typically going to be PVC, and it comes in there's a couple of different configurations, but this is what the water kind of drips over, and this is where the magic happens. This is where the heat of the fluid of the water gets transferred to the air. Now you're going to have the sump, and that's going to be on the bottom. Now the sump actually, and this is another thing that I found interesting when I not all cooling towers are the same. You're going to have sumps that some are indoors, some are outdoors. That's two different options. You can actually have an indoor sump, and I've seen a couple different configurations, especially if you have something that's going to be operating all the year round. They don't drain the cooling tower in the winter to prevent freezing, because they don't need it. They can use free cooling. There are some places where that's not the case. They keep it around all year, and they found that it's economical to have this large sump, and they put it on the inside. So that's an option, when you're thinking about design. It doesn't always have to be outdoors. If you do have multiple cooling towers that are side by side, you're going to have some sort of connectors, depending on your valving and how the piping works. And these connectors are from sump to sump to sump, so you don't end up filling one sump say you had 3 cooling towers. You don't overfill one sump and have it, flow over, and then the other 2 sumps are, don't have as much water. You want to keep them all about the same level, so it drains at the same rate. So, and a couple of different things that you're going to have. If again, this is going to be for the freezing temperatures, you can have immersion heaters, and I'll go into those a little bit more. But that keeps it from freezing solid, so you can kind of continue to use it. But that's generally located in the sump. Now, another important component that tends to be very problematic, as opposed to the PVC drift, the fill. That occasionally needs to be cleaned, or sometimes it gets brittle, so it breaks and it needs to be replaced. Generally not a huge expense. The water fill line, very problematic in a lot of cases. Generally, it's going to be a float ball, so when the water level goes down, it's just like a toilet tank. When the water level goes down in the tank, it's it opens up the fill valve, and it's going to fill until the float ball comes up to a certain level. So it's very rudimentary. There's some cases, and a lot of cases, where this float ball gets stuck. So you're continually filling the sump. Obviously, you're going to have an overflow and an overflow sensor, or you might, in some cases, you may not, but you may not be able to detect it. So if the float ball gets stuck and you're filling the sump, it's just going to overflow. So that is a waste of water, and you need to catch that. Now, obviously, since the water fill line, a lot of the tower water is going to be evaporating. There's going to be a metering requirement. Now, this is less to do with energy, more to do with water conservation, and to avoid sewer charges. Because if you can meter the amount of water that goes in, and obviously you're going to maybe monitor the overflow or the blowdown that comes out, you can take that differential, and that's just evaporated water that you don't necessarily have to pay for on the sewer charges. So you want to be able to avoid that. So that's why there's extra metering there at the cooling tower. Now, the blowdown is important because obviously the water evaporates, but it doesn't take with it the dissolved solids, any sort of muck and crud that gets filtered in or filtered out of the air by the cooling tower. So that's something that you need to blow that down occasionally for a cooling tower, just to keep those total dissolved solids at a respectable level. Obviously, if you don't, that's primarily going to affect your chiller. When it goes back to your chiller, it's not good. Final word, obviously, water treatment. You need to have chemicals to control the biologicals. I have a whole separate talk about this, especially with Legionella. That's one of the hot topics with cooling towers. But go ahead and listen to that episode, and I'll link it up in the show notes for those who are interested. All right, so what are some of the issues around cooling towers? Now, obviously, we know that they're an open system, they're larger, and with anything that's going to be on the roof, architects love to hide it. So knowing the location of it, knowing the clearances that are required to prevent the re-entrainment, obviously the re-entrainment will lead to derating. That's a big problem with cooling towers. They need to have room to breathe. So there's really fine requirements as far as where all those issues have to be. Things to think about: variable flow. Just because you have, I know there's a lot of energy savings that go along with pumps and fans. You got a VFD on the fan. You can also do a variable flow on the pumping system to save pump energy, which is pretty big. But you gotta watch out for partial fill coverage. So if you have some isolation valves that don't work properly, or maybe you don't have any at all, you could run into a scenario if you have multiple cooling towers where the fill is going to be, where it's going to go up to the fill, and it's not going to spread out like it should. So you're going to be derating the fill, or you're going to be derating the capacity of the tower just by not flowing enough water through it. So just like many devices, there should be a minimum flow that's flowed over a tower to be able to make sure that you get the desired result that you want. Along with that, isolation valves. Isolation valves, especially when you're commissioning it or troubleshooting it, obviously it's a great idea to have visible indicators on these valves. These valves are bigger, so there's ones that are okay as far as being able to see it from a distance. But if you can't get, and obviously cooling towers can get 14, 16 feet in the air, you may not be able to get real close to these valves. So anything that can help you identify whether a valve is open or closed, whether it's isolating it or not, is really going to be a help to you as commissioning or whether the maintenance people, just to be able to understand what position the valves are in. So visible indicators, I've seen some that are nice bright and yellow, and if they're closed, they're red. So that's a nice contrast. Very visible for you to see. Obviously, if freezing is a concern, and here again we're talking about the sump heaters, you're also going to have heat trace. Heat trace is for for the piping, for the water fill line. You're going to have heat trace to make sure that doesn't freeze. And again, an easy and relatively inexpensive way is just to make sure that there's run lights. So if it's on, that you can verify that, yes, in fact, it should be working or it is on, and, you can check the sump heaters, and you can check the heat trace on the piping, because those things are really hard to, unless you have a thermographic camera, you're not able to necessarily tell whether they're on, whether they're doing their job. And just having a red indicator light, just saying it's on, is very helpful. Also, pump location is very important. Pump location, now, especially if you're dealing with something with an indoor sump, pump location is going to be very critical. I've had a scenario where I had an indoor sump and the pumps were right next to the indoor sump, and there wasn't a lot of elevation change. There might have been 6 feet from where the pipe came out of the indoor sump down into the suction inlet of the condenser water pump. So that's critical in a couple of different applications, depending how full the indoor sump is. And this was a problem we were running into when it first started up. It just sucked all the water down. And what it did is it created this vortex in the sump at the outlet of it, and that air was getting entrained into the pump. Now, we had to actually add in some sort of anti-vortex, basically just kind of a cross, a metal plate that was at 45 or at 90 degrees to each other, and just stick that into that, and that would break up that rotation of the fluid as it exited the indoor sump. So that was one of the solutions that we had to kind of implement, which is, getting into those indoor sumps is not always tricky. It's a confined space. It's not always tricky. It is always tricky. It's a confined space. You need, special requirements to get in there, because a lot can happen in a short amount of time there. So, freezing concerns, the air entrainment, the pumps. It was one of the few locations as an engineer that I really ran into the net positive suction head requirement for that, and it was that particular instance, because it was so close. You didn't have a lot. It's an open system, so you just didn't have they didn't have that huge column of water pushing against the inlet of the pump. So net positive suction head was an issue there. So we need to make sure that the levels were right. Now, obviously, other things you can have, side stream filters are something else that I've seen on the cooling tower loops, just to filter out all the muck that can get entrained in the system. So filters are a big concern with the cooling towers. A lot of them have screens, large screens, and they're There's just about anything that can get stuck in a cooling tower. Wouldn't surprise me really at all. So that was basically kind of some observations that I had over cooling towers. So I hope that was helpful. Thanks so much for listening. If you know somebody who looks or is looking for more information about this topic, consider passing this episode along. If you're not a subscriber, consider joining the growing community of people just like you over at HVAC360.com. And don't forget about the membership deal. Lastly, I'd be greatly honored, again, if you would consider leaving a review and rating on Apple Podcasts. Obviously, the offer still stands to give you a shout out. I really do appreciate those. Well, that's a wrap for this episode of HVAC 360. I'm Matt Nelson, helping you be the best and the brightest in the field of HVAC. And as always, know what you build and share what you know.